Hello friends. Welcome to my YouTube channel. Have you ever wondered what voltage, current, resistance, and power really mean in electricity? Actually, these four terms are the foundation of every electrical system, from a simple mobile charger to massive industrial substations. In this video, we'll understand all four concepts with simple examples. Let's get started. Let's start with voltage. Voltage is the electrical potential difference between 2 points. In simple words, voltage is the force or pressure that pushes electric charges through a circuit. Think of a water tank connected to a pipe. The water pressure inside the tank is similar to voltage in an electrical circuit. Higher pressure means water can flow more easily. Similarly, higher voltage provides a stronger push for current to flow. For example, in our homes, the supply voltage is approximately 230 volts AC between phase and neutral. This 230-volt potential difference pushes current through appliances like fans, lights, and televisions. Remember, voltage is the push. Now let's understand current. Current is the flow of electric charge through a conductor. When voltage is applied across a wire, electrons start moving. This movement of electrons is called electric current. Current is measured in amperes or amps. Imagine water flowing through a pipe. The amount of water flowing every second is similar to current. More water flow means more current. For example, if a bulb circuit draws 2 amperes, it means electrical charge is continuously flowing through the circuit to operate the bulb. Remember, current is the flow. Next comes resistance. Resistance is the opposition offered by a material to the flow of electric current. In simple words, resistance acts like a roadblock in the path of electricity. The higher the resistance, the harder it is for current to flow. Resistance is measured in ohms. Let's take an example. Suppose we connect a 12-volt battery to a 6-ohm resistor. According to Ohm's law, the current will be current equals voltage divided by resistance. That gives us 12 divided by 6, which equals 2 amperes. Materials like copper have very low resistance and are excellent conductors. Heating elements, such as those used in electric irons and heaters, have higher resistance, which helps generate heat. Remember, resistance is the opposition. Now let's understand power. Power is the rate at which electrical energy is used or converted. Power tells us how fast electrical energy is being consumed. The unit of power is watt. The basic formula is power equals voltage multiplied by current. Let's take a practical example. If a device operates at 230 volts and draws 2 amps of current, then power equals 230 multiplied by 2. That gives us 460 watts. This means the device consumes electrical energy at a rate of 460 watts. Higher power devices like heaters consume more energy compared to low power devices like LED bulbs. Remember, power is the rate of energy US. Now let's connect all four concepts together. Voltage provides the push. Current is the flow. Resistance controls the flow. Power tells us how much energy is being used. A simple way to remember is, voltage is the push. Current is the flow. Resistance is the opposition. Power is the work done. If you found this explanation useful, don't forget to like, share, and subscribe for more electrical engineering content. Comment below which topic you'd like us to explain next. Thanks for watching and see you in the next video.